All right. So homework for today was to re-implement merge sort using multiple threads. How'd that go? Bad. Shouldn't it have been easy? Just replace your recursive calls with threads? Threads in a two threads in a join? Hey, okay. Well, let's see what we can figure out here. Hopefully I don't embarrass myself trying to solve it. All right, we already started working on this merge sort worker bee dealy flippy thing. Let me get over to the all right. We already started working on the what happened? Ew. Oh, that's still up there. I don't see on my screen what you got. Now I see that now. What is going on? So okay, well, so that's back up there. Okay, so I need to do that. That's a okay. Then I need to say all right. All right. Let's assume that we're in good shape now and let's go from there. All right. So last time we had created this merge sort worker bee, and I started giving you a starting point for this. We talked about threads and how to have threads wait for other threads. Uh, so notice that merge sort worker bee here is a thread. So I extended thread, which means he comes with his own public void run method that actually does nothing. Okay, so we're going to override that and write our own version of this. And what we want this guy to do is we want him to handle the merge sort on AR from begin to end. Okay, so this is going to be our merge sort algorithm, but brought into an individual thread, but having that thread only work on the portion of the array that it's supposed to work on. All right, so let's go back to our main here and let's grab some of our merge sort stuff. All right, so I just copied that. Right, we had our try catch stuff in there from our thread before. We'll just get rid of that for right now. All right, so now I'll go ahead and I just pasted my merge sort code in here. So inside of run, from a particular merge sort worker bee's perspective, he's going to be working with this.ar. So I'm going to go ahead and update these to be like this.begin, this dot. And even though you wouldn't have actually needed those, because remember, variables resolve to their most local definition. So begin would have already worked, but I like to fully reference it and say it is this instance of merge sort worker B's version of begin, which was set when we first created an instance of merge sort worker B and passed it in the array, pointer to the array, the beginning and the ending that this worker B is supposed to work on. All right, so first thing I'm going to ask inside of this thread's runtime is, are begin and end not equal to each other? If they're not equal to each other, I need to do some work. All right, so we're going to figure out a begin one and end one, a begin two and end two. And then right now we're making two calls to merge sort. That's the part we no longer want to do. Instead, what we want to do is we want to create two threads, two merge sort worker B threads that we can pass the array to along with begin and end. Okay, so we're going to say, let's get the copy the name of this guy here. All right, so I'm going to create an instance of merge sort worker B. We'll call this guy WB1. It's going to be equal to a new merge sort worker B, passing it AR, begin one, and end one. I'm going to do the same thing for worker B2. Except we're going to pass this guy begin two and end two, or two halves. Now we'll no longer call our recursive merge sort calls. So instead of calling our merge sort calls, now an important piece here, understand we've only instantiated our threads here. We haven't actually started them. All right. So to start this, we would say WB1.start. So now the worker B in charge of working on the left-hand side of my sub list is off to work. WB2.start. So the guy in charge of working on the right hand is off to work, and they're able to work simultaneously. So right off the bat, we're seeing an immediate speed up from what we had recursively. Because recursively, when we had two calls to merge sort, we had merge sort followed by a second call to merge sort. That second call did not get called until that first call completely finished, which involved a whole bunch of other internal calls to merge sort. That makes sense? So now we're saying, hey, we can work on the left half and the right half at the same time. No problem. But we need to make sure that we don't go and start our merge step until the left half and the right half have completed. Make sense? So what we need to do is we need to wait on WB1 and WB2. Okay, and if you remember, we looked at the documentation. We had a, hide this here, inside of the thread class, I think it's a static method called join. Let's see, not static. That was for the wait. All right, so this guy's called join, and this guy waits for the current thread to die. So I need to join WB1 and join WB2 so that the current thread that's running inside of this worker B waits for those guys to finish before he goes on. We need to force him to block. All right, so we're going to go into the code here, and we're going to say WB1 join, WB2 join. So this is wait for the worker bees to finish their tasks before I merge. Worker bees are now done, so I can continue. All right, so once I get to this line right here, it's because WB1 has finished and WB2 has finished. All right, so I'm effectively forcing this thread to block while these other threads go and do their job. this becomes kind of how do you divide up labor and making sure that you don't go and finish a task before the setup for it is done. All right. So WB1's job is to sort the array from begin one to end one. WB2's job is to sort it from begin two to end two. And then this particular instance of my worker B, so which is this, right? Which is a thread. We're going to tell this guy, go ahead and join WB1. Join WB2, which means you're going to wait on those guys to both complete before you go and do a merge. After that, he can go and do his merge step. Should be the same logic as we had before. I'm going to, again, go ahead and say this dot end minus this dot begin. I like that syntax, making sure we specify it as the begin and end associated with this particular instance of worker B. Those were values that were passed in when we first instantiated this worker B. All right, so we'll create a local variable temp. Begin one and begin two, these are local variables inside of the run method here. So we don't put this in front of those. Go through our for loop, ask some questions. We are talking about the global AR. There isn't a local AR. So if you just leave AR like this, it's fine. But again, I like to be explicit. I'm talking about the array, the pointer to the array that this particular instance of worker B has. So anytime I see the AR, I'm going to say this dot AR. It actually does give a slight speed up because we're not relying on the language to resolve the variable and look locally, then look a little bit less locally, and ultimately find it at the top. We're telling it, go and the guy I'm talking about, this dot AR, is the field up at the top of this class. All right, so there is actually a speed benefit of doing this as well. But I also think the syntax really drives the point home here. Okay, and again, this dot begin to this dot end. These are fields associated with this particular copy of merge sort worker B. So we're going to copy over that place in memory with whatever was in temp. Okay. So that should be it for this run method, right? So run method is only going to do stuff if begin and end are not equal. Okay, if they're not equal, we're going to figure out the left and the right half, spin up a thread to deal with the left half, spin up a thread to deal with the right half, tell each of those threads to start, then wait for both of those threads to finish. Then do our natural merge step back to put the things in the correct order. And then this thread will finish, which is then going to cause his parent, the guy who spawned him, to continue going because he's been waiting on this guy with his WB1, WB2 join. All right. So out here in our main program, I'm going to go ahead and dump our merge sort. We'll keep our display function here. All right, so we went ahead and created our array. We filled it up with some random numbers. We created a single worker B, passing it the array and passing it a begin of 0 and end is the last legal bucket. We told that guy to start. Now, if we want to, we can go ahead and prove we have an unsorted array here. So right after we filled our array, we can go ahead and display it and show like, hey, here's your array all out of order. Then we'll create our worker B, giving him the full array. So this is a single thread that we're going to say, go and do merge sort. All right. We'll tell that thread to start, but then we're going to tell main here to go ahead and wait for that thread to finish. Okay. Once that thread has finished, then we'll go ahead and have him say I'm back. That'll let us know that, he's now gotten control back, and we'll go ahead and display what should be the updated version of AR, which should now be all sorted by the multiple calls to, multiple threads. All right, makes some sense. Oh, that's the exception from last class. I took the try catch out. So remember, we talked about last time that this WB join thing, this is something that could cause an error when we wait for things. So what we can do is you can either throw the exception or you can do a try catch. I'll just do the try catch thing. I'm just going to put my entire run function. The loop. And then I'll catch exception E and do nothing. Just highlight everything in the middle here. And indent that. So now I've just wrapped that stuff, all the stuff inside of a try catch, even though it's only these two lines that actually can throw the exception. So if I wanted to, if I had code that was possibly throwing multiple exceptions, maybe I would throw my try catch just around portions of it and catch certain kinds of exceptions. But in this case, I'm kind of doing the quick one and done and just trying all the bad stuff. And if something bad happens, we'll catch the exception. Otherwise, it'll let it run to fruition. So there is our multi-threaded merge sort. Is it in order? Okay. So that guy is showing us, it's not drastic speed up because we've interjected some blocking, but rather than our code blocking by default, we've given ourselves the ability of doing some things asynchronously. All right, so I want to introduce those couple of words here, and then we're going to dive into Unity. Okay. So before I go and talk about asynchronous versus synchronous, any questions on this guy? So just out of curiosity, those of you who ran into some barriers with this one, where did your problem end up being? Good. Sort the variable. Okay, well, that's the result of the problem. But now that you saw the solution, what was the piece that was missing? Or you have to still go back and figure out what... Okay, so from your perspective right now, it seems like you've done the same thing. There must be some line. Yeah. Yeah, my best guess is the points of weakness here are going to be whenever you do your joints. So make sure you wait here after you've started your first worker bee, and then make sure you wait here after you've started your other two. But make sure you start your worker bees first. Those are usually your points of contention. If after that, your next weak point might be dealing with begins and ends, talking about local variables instead of global variables, something like that. That's where I really like using this dot when I'm definitely talking about those dudes. So I see those as maybe your two most likely culprits for a problem. Because otherwise, like I said, I mean, it's a pretty straightforward thing, but if you miss one of those little stop the block things, your threads will do the sorting, but you've already printed the unsorted version of the screen because nothing stopped. Nobody waited for anybody else. All right, so blocking versus non-blocking terms. And this is really just going to be a quick slide. So you're going to see things like this. So we've introduced this concept of threads now, which allows us to bypass the default behavior of a programming language where a line can't continue until the line before it completes, right? All right, so by default, our programs run linearly, right? We do line 1, then line 2, then line 3, then line 4, so on and so forth. What we've done now with threads is we've given ourselves the ability to say, the next thing I'm about to do is going to go off and do something that's unrelated to some of these other things. So I want both of those things to potentially happen at the same time. Okay. And that's called an asynchronous call. Go ahead.
If we join it to like block it from doing something else before it was done, why did we use the word join? Why was it that one?
Oh, that's what the documentation says. If you look at the documentation for thread, the function join waits for this thread to die. Yeah, so we say wb1.join because we're going to wait for wb1 to finish. That's just the syntax for it. If there's a little bit of a confusing piece with that, it's that code makes the assumption that about who's waiting. Because if we look back at this guy here and go into our worker B, when I say wait for worker B1 to die, that's what that line right there says. The question we might ask is, well, who's waiting? Because we're not using this dot in there or anything like that. So built into the thread library, since it's doing some magic, it's the current running thread that's waiting. So there is a little bit of an assumption we're making there about who's doing the waiting for this guy. In this case, it's this guy, this running thread is waiting for this guy to die. And this is the current instance of merge sort worker B, which is a thread. Okay, but I could see that being a little bit of a sticking point logically, because you're never actually telling this particular worker B to wait for that worker B to finish. That part gets assumed. Does that make some sense? All right. So blocking versus non-blocking, I want us to understand those concepts because by default, our programming languages will block. All right. Anytime you have code that's going to go and do something, you don't get to the next line until it finishes. If we want to choose to bypass that, we would try to create non-blocking code. So we're going to say asynchronous. And actually, these are words that became much more part of our normal everyday lives during COVID, right? When classwork started becoming, oh, we do asynchronous classes versus synchronous classes. So really can use that knowledge to talk about this. So asynchronous means that, the thing is off doing its own thing. So if you were attending an asynchronous class, I would give the lecture, I'd record it, I'd put it up on YouTube. Whenever you're ready to view it, out of sync to when I gave the lecture, you can go and view it, right? So asynchronous is happening off on its own, all right? As opposed to synchronous means that I'm giving the lecture at the same time you're on Zoom watching the lecture, and we're synced up. We're doing it at the exact same time. So we would say that in general, programming languages behave in a synchronous way by default, and we can choose to move them to an asynchronous behavior by using tools like threads. So having something happen in the background that does not block the rest of the program flow by default. Even though we saw in this assignment, we purposely went and blocked when it was time to block, right? We said, okay, well, we can't just let those guys go and do their thing and then keep going, because I'm going to end up printing out what should be sorted, but it's not sorted because I didn't wait. So we only got a little bit of speed up here because we let the left and the right half happen at the same time, relying on the operating system to decide when those threads get CPU time and that stuff. But so we moved out of a synchronous default state to create initially one asynchronous thing to start merge sort, and then each call to merge sort created two asynchronous events, right? A worker B for the left and a worker B for the right. But then each time we then dove back into the synchronous world while we waited for our worker Bs to do the left and the right side. All right. So we probably doubled our performance, I guess, by letting the left and the right side happen simultaneously, getting as much CPU time as they possibly could get, rather than literally having to have the right side fully wait until the left side was completely done. I'm sure we can probably do some looking into that and consider the overhead of switching between threads and context switching as an operating system term, and maybe find out we didn't gain as much performance as we maybe would have wanted to, but hopefully we still saw the value in this idea of having things run in non-blocking ways. All right. So sometimes when you want something to happen without blocking the rest of your program, you do this in an asynchronous way versus synchronous. Having the program run linearly, where each line must wait for the previous line to finish before it can execute. All right. So now this allows me to introduce one other thing that's common in modern software development. Um, it's actually something we're probably not going to, well, we might see it a little bit in Unity, but it's not really a clear-cut example in Unity. But we do have something here called callback functions. Different languages, different technologies have maybe different names for this, but a callback function is a function that gets called upon an asynchronous event completing, which notifies us of the completion so we can move forward with the next steps. So this is kind of an alternative to joining, except in our case here, we didn't really have anything better to do than to wait on those threads to finish doing their sorting thing, because the very next thing our main program wanted to do is display the sorted array, right? But let's assume that our, we were doing something with, I don't know, authentication or something like that, where we have 20 different users who all want to, log in at the same time. After the first person tries to log in, we spin up a worker bee to authenticate them. We might hand that off while we turn around and we wait for the next person to try to log in. But as soon as they completely log in, that might notify the main program here that, okay, we have a new user, and they might then go and do some stuff, adding them to the current list or showing them in a room, putting them in a room, something like that. So we do have a way of almost getting like push notifications like you do on your phones, where the app itself notifies when some event has occurred, rather than you having to sit there and wait for it to just die. Join says we're only interested in one event, and that is that thread's death, and we're just going to sit here until it dies. So there's a built-in callback with that, with join. But we can actually create functions. The official term for is something called a closure, which function as callback functions. This is a function that will get called upon completion of an asynchronous block of code. And then you can have that callback thing happen as like the very last step, the thing that maybe starts your program up again, or finally displays the thing sorted, whatever, that kind of stuff. All right, so callback functions are something you're going to find in a lot of languages. If you've done any sort of JavaScript stuff with web, callback stuff is all over the place. Some more modern languages like Node.js, they call this a promise. So it's kind of like, I promise I'll call you back, that type of thing, where whenever it finishes its thing, it calls back. Synchronous, this is just our default behavior. Okay, so a couple of terms to kind of close those gaps, because as you get into different programming languages, there will be situations that pop up where you say, oh, I want something to happen simultaneously to something else. As soon as you think about that, you're going to ask yourself, okay, then in this language, how do I make an asynchronous call? What does that mean in this programming language to make an asynchronous call? Here in Java, we just created our own thread and told it to start, poof, asynchronous. Other languages, you might do it a little bit differently. Sometimes you'll embed a little asynchronous code block where like you only want 3 lines to happen on the side or something. So rather than go and create an entirely new class, you can kind of just wrap this closure, those 3 lines inside of an asynchronous call and just have it all magically happen inside of this little cluster. Whatever's the right tool for the job, but every modern language has some ability of doing things in the background, multi-threading, and usually it's done through something called an asynchronous call. All right, questions on any of that stuff before we dive into some starting stuff with Unity? Okay. So I did mention last time, if you download Unity, if you haven't already done this, go ahead and get Unity downloaded. The link's on the website. When you download it and install it, it'll open up this thing here called Unity Hub. Then you want to go to installs. And I went ahead last night and I uninstalled my other stuff and installed the latest, greatest. So I'm running 2022.3.17 F1. So this is their long-term support. That's what LTS stands for. So this is their version of Unity that is what they would ask you to use if you're making production applications, even though there are some other, if you go to install editor here, there are some pre-releases. So you can look at the 2023.3. So these are beta releases, which probably are stable enough, but might have some new bells and whistles in there that haven't quite been tested out. The stuff we're going to be doing in Unity in this class is going to be very primitive Unity stuff. If you're really interested in game development, you'll take those primitives and go and make them look fancier. So you're not going to need the beta stuff in here, but usually their betas are pretty mature. So I don't think there's a huge risk. Anything that says alpha on it, those are higher risks typically. One interesting thing to consider with this skill set that we're going to learn here with Unity, and I think this is actually, really pretty exciting for this group. How many of you have heard of the Apple Vision Pro? Okay, so that's Apple's augmented reality headset that's was pre-order started last Friday and it comes out on February 2nd. So the department will have one. They're not cheap, right? $3,500 for an Apple Vision Pro. But what's interesting about it is I think so I've been doing this for a while and I get involved with new software products as they come out, and I was very early on the App Store with iPhone. I think this is an opportunity for software engineers to start coding in a kind of a new ecosystem that Apple's going to create. Apple moves mountains, if you will, in the tech industry. So whether you like them or not, the fact that Apple is having a high-end device in the virtual and augmented space, Apple doesn't want to call it that. For all of us developers, they actually say we are not allowed to call it virtual reality or augmented reality. We can't say VR or AR. We have to call it spatial computing. So Apple's trying to create let's call it a new field. And we've seen Apple do this several times in the past where I would not bet against them. When iPhone first came out, iPhone didn't support a product called Flash, which everybody used. Guessing most of you in here have no idea what I'm talking about when I say Flash, but trust me when I say the entire internet ran on Flash. Early iPhone, well, iPhone never supported Flash. And everybody yelled at Apple and said, oh, you're ruining everything. And, nobody's going to like you and blah, blah, blah. And when Apple was saying, if you want to do the same stuff Flash did, you have to adopt HTML5. Well, what's the standard today? HTML5. Nobody's heard of Flash anymore. it's dead because Apple killed them. All right. So typically Apple's a big enough fish that when they jump into a field and they start renaming terms, that's a fairly good indicator that this is going to be a kind of a new ecosystem. So something that's fairly exciting, I think, for us computer scientists. The reason I bring it up here is even though Apple would want you to use all of their native tools for writing software for the Vision Pro, you actually can do all of your immersive stuff for Vision Pro software development using Unity. So the skill we're learning here, you can use for making Xbox games, PlayStation games, PC games, PC VR games, Quest games, anything 3D, you can make it. All your VR software development can be done in Unity. All your normal 3D software development can be done in Unity. Even 2D games, platformers and stuff, Unity has like things for it. It's probably not really made for that, but it can pull it off. But this one skill set will allow you to deploy to multiple different things. In fact, when you were installing Unity, I saw this last night when I was installing it, this latest version of Unity, when you click on the support that you want to have for installing, for you only need either Windows or if you're on a Mac support. But if you want to write software for the Oculus Quest or MetaQuest, you need Android support. That runs on the Android operating system. You want to write games for iPhone, you need iOS support. But one of the options now is also Vision Pro. So if you want to write stuff for Vision Pro, you need Vision Pro support. And ultimately, that doesn't change the way you use Unity outside of just maybe obviously with something like Vision Pro, there's going to be certain primitives that make sense in Vision Pro, but that don't exist on like an iPhone. So, Vision Pro, when you're writing an application, you kind of have like two different ecosystems. You can either have a window-based application where, it's presented to you as a single panel, or you could put multiple panels in different places, or they have something called a volume, which means that you're putting stuff out into your three-dimensional space in front of you. So Unity is going to have things for bringing a window in or bringing a volume in, and those things a volume wouldn't make sense if you're writing an iPhone app. So there'll be some new stuff added to Unity for if you're writing software for those things. But largely when you say you want build support for Unity for these different things, what you're really saying is when I'm done writing my game, however the game was written, and I go and I want to create an executable to deploy it, you choose what your target platform is. And if you want iPhone to be one of those, you need to have had iPhone build support. If you want Android Quest to be one of those, you need to have had Android build support. Same thing with Vision Pro. If you're doing anything on the Apple side of things, though, you really are going to need a Mac in order to ultimately get it across the finish line. And even more so now, it seems like basically everything Apple's releasing now kind of requires you to be on Apple Silicon. So not even Intel-based Macs. You need Apple's either M1, M2, or M3 processor in your machines. But in any case, kind of an exciting thing that you're learning about a tool that not only is used for making all these other things, but is now used for making Vision Pro apps if you end up wanting to get into that. I think there's an opportunity over the next probably year to make some decent money on the Vision Pro App Store if you can come up with some neat app ideas that make sense in some sort of virtual space or something like that. It's got to be a reasonable idea for an app, but you got to consider that you can probably charge a premium for those apps because realistically, early adopters of Apple technology are probably going to not have a problem spending $50 on a piece of software or something like that when they just drop $3,500 on the device. But something to consider. I think it'd be a cool project to work on, go through some tutorials or something like that. And it's an interesting opportunity for us to do those things. And like I said, we'll have a Vision Pro if you want to be able to test your stuff on it. All right. So just as a starting point here, I'm going to just kind of dive into Unity. And what I'm going to do is I'm going to put up a tutorial that I want you to work through to kind of bring you up to speed on Unity during this week. I'll probably have you do it in a couple different pieces. So I'll give you a piece of it that starts off that'll be due on Wednesday, and then another piece that'll be due on Friday. You could really sit down and do the whole thing in a single sitting, but I bet you would probably take something like 2 or 3 hours. So probably a similar amount of time you've spent on your other homework, but it's going to be more of a monkey see, monkey do. You watch them say, oh, do this, click here, do this, but it introduces you to the primitives of Unity pretty quickly. And the product we're going to make is something called Rollaball. I actually have the thing down here. It's possible it's out of sync, so I'm not even going to show you that one. But it effectively is going to be a 3D game where you're controlling this marble, and you drive it around, picking up, coins or something like that to earn points. It just shows you some real basic stuff that you imagine exists in video games in a small, ecosystem that doesn't take 6 months to go through. All right. But just to give you an initial idea, I'm going to click on new project here. And it has a bunch of templates. Usually you're going to use 3D core, but notice they have some other startup templates and stuff like that. They have a VR core if you're writing VR game stuff. But 3D core is usually where everything will start. Typically, when you use Unity, what you're thinking about is I'm making a 3D application. Okay. For us in here, I want our focus to still stick with the code. So we're going to be still writing a lot of scripts behind the scenes, using inheritance, things like that. But we're building a user interface that exists in 3D space. And you're going to see that that's not really that big of a deal. All right. So we'll call this guy CSC250 Spring 2024 Project 1. And I'll just let it put it wherever it's going to put it. All right. And I do have, you can get an account with Unity. A student account's free. So I would go ahead and do that. So you can have that stuff up there. Connect to Unity Cloud, Unity version control. I'm not sure on the version control thing here, but I definitely want to look into that, because one of the things that is a challenge is I'm going to have to teach you how to use GitHub. And it'll be a little bit of a challenge. So for next class, I'll look into this, but doesn't matter what you click here for right now. So I'll just say, well, here, I'm going to click that just so I have access to it. Yeah, it looks like it creates a repository. I'm going to click that for now because that might be how I want to do it. So I'll just create this project and you'll see kind of what this main screen looks like. I know we're in our final minute here, but let's just get it started. So basically what you see when it pops up here is the starting point for any Unity application. There are ways for you to reorganize some of the panes to put them in places that are a little bit easier. That'll make sense once we start dragging stuff around. Because a lot of times what we're going to do is in the middle, we're going to have our kind of our three-dimensional space. So we might create a new 3D object like a sphere or cube or something like that and place it out there. And then over on the right side, we have attributes associated with that guy. One of those attributes is its location. It's called a transform. So that keeps track of where is it in 3D space, what its rotation is, and what its scale is. All right, but then there's some other things we can add to that, like scripts. We can add behaviors to our objects that run our programs, and that's all going to be on the right-hand side. So you'll see sometimes we might want to reorganize this a little bit. When you first come in here, you get something that looks like this. If I want to add something to my space, I can right-click over here, and I can create a 3D object, create a cube. So here's that cube. I can zoom in on it, and you can... with the mouse, you can do all sorts of different things. But when I select that cube, notice here's the transform here for that cube. I can change its scale over here, either numerically, or I can drag stuff around in here. So you're going to get used to this cadence of bringing different 3D objects in there and then hanging abilities onto those. All right. So I will put up the starting of that tutorial. Give me until a little bit in the afternoon to do it, because I want to make sure I tell you the right steps. I'll get the tutorial up quickly. Let me just try to do it pretty quickly here after class so you can get started if you want. But start off by getting Unity installed and everything. All right, I'll see everybody on Wednesday.
See ya.
Later.